Hello everyone, we're on lesson number 3 talking about logarithmic functions today. So let's talk about what a logarithm is. A logarithm is just the inverse of an exponential function. So here you see an exponential function, and here we see a logarithmic function. It says log base b of x is equal to y. So as long as we have our base greater than 0 and not equal to 1, we can write a logarithmic function, which is written this way with our base of x equal to y. We just take our base, which is always going to be the same, and basically our x and y's switch place on the equal sign, right? So we have log base b, we have exponential with base b. My y is over here on the opposite side of the equal sign. It's going to end up becoming the power, right? And then my x switches sides. So when they ask us to go back and forth, right, because they're going to be asking us to write it in either exponential or logarithmic, we're just going to be moving some things around. Okay, let's take a look at what those examples would look like. Here we have log base 3 of 81 is equal to 4. We want to write this in exponential form. So my base here is 3, and as we notice, our base is always going to stay as our base. So we're going to keep that 3. The only thing that really changes now is my y, which is 4 in this situation, becomes my power. So I had equal to 4. That's now my power. And my x here is what my log is going to be equal to. Going the other direction, again, our base doesn't change. Right? So I know my base here was 8. It's going to remain my base here as well. However, now we're working in log form. So I have log base 8 of this value, 262,144. It's going to be equal to 6. Because remember, I mentioned these always switch places. Okay, so there's two problems for you to try right underneath. This one you're changing the exponential form. There should be no log present in the end. This one you want to change to logarithmic. You want to make sure that you have log present when you write it down. So pause the video and resume it when you're ready to check your solution. All right, let's see how you do with this. You want your base to remain as a 7, and we're basically just going to switch these two. So I know 9 becomes my power, and it's going to be equal to x. Eventually we can figure out what that value will be. The other one that you were to try is change it to logarithmic form. So I'm going to write down log first this time, and I know my base is also going to stay as my base. So we've got log of 625. I'm just going to switch positions with these now. So 5 becomes my power, and then the 1/4 is what it's equal to. I don't think I used the right term when I said power there, but I think you understand what I'm saying. Okay, then you're going to have problems similar to this where they ask us to evaluate. Now, normally when they say evaluate, we're not going to have equal to x. But to make these problems a little bit easier, we're going to make them equal to x. Why? Because we're going to change them into exponential form. And once we do that, we can start solving them, because that's what lesson 2 is all about, solving exponential functions. So let's do that right now. Let's change this into exponential form. So my base of 32 is going to stay. I now have a power of x, and it's going to be equal to 2, because we just switched places. What I want to do now, just like we talked about in lesson 2, is try to make that base match. What I'm thinking here is 2 to the power of 5. That's still going to be to the power of x, and that's going to be equal to 2. And I'm just going to write to the power of 1 here, just so I remember. A little bit more left to do. We've got to multiply these values. So this side is 2 to the power of 5x equals 2 to the power of 1. Once we have the same base, we can just work with the exponents. 5x equals 1, divide by 5, and we get x equals 1/5. Okay, we're going to try another one. Here they give us log base 6 of 36. We're going to make it equal to some number. That's what we're trying to figure out. We're going to change it into exponential form. So our base 6 to the power of x will be equal to 36. Alright, well the 6 isn't going to change, but that 36 we're going to rewrite as 6 squared. Now that we have the same bases, we can just work with the exponents. Here we get x equals 2. Not much else we can do with that problem. Okay, so there's a you try problem right here. Alright, it's log base 243 of 3 is equal to, that's an x. I'm sorry that it looks really weird, but try this problem out. Pause it and resume when you're ready to check your solution. Alright, let's see how you did here. We know that we're going to have 243 to the power of x equals 3. Now, I can't change the 3 at all, so I'm going to have to change this 243. A good idea is that because I want these to be the same base, this is probably going to be 3 to some power. In fact, it's going to be 3 to the 5th. Now, this side, I'm just going to put a 1 here. I'm going to multiply my 5 and my x, so we have 3 to the power of 5x equals 3 to the power of 1. We have the same base. Now we can just work with the exponents. 5x equals 1, divide by 5. Our solution here is x equals 1/5. Hopefully you got that answer for that problem. We got a little bit more to talk about. We're going to talk about parent graphs and some transformations. Now, some very similar things to graphing exponential functions. We're going to have 3 critical points. And if you remembered, with exponential growth and decay, our functions for growth kind of went like this. Alright, but now what's going to end up happening is returning these this way, and you're going to see your functions kind of go like this. Okay. What do I mean by that? I'm going to show you right now. 3 critical points. Our first critical point is going to be right here at 0, 1. And notice, just like before, we have that unit, which happens to be 1 unit apart from the y-axis, which, by the way, that's where our asymptote is now going to fall. Okay, so we've got 1 point already, and I'll label that 1, 0. The second point that we're going to work with, our second critical point, is going to be out here at b. When we plug in b, we're going to get 1 out. And lastly, if we do this point here at 1 over b, we're going to end up with -1 as a solution. I neglected to mention, by the way, that this is when our b value is greater than 1. So something like log base 5. This is what the general shape would look like. If that was a 5, this would be really close to be 1/5 the distance. This point would be out here at 5. Okay, this point always going to be at 1, 0. Here, when we're talking about our base being greater than 0 but less than 1, that'd be something like 1/2 or 1/3. Okay, our base. Pretty much this whole thing is just going to flip. Right? If we plug in our b value, which is now a fraction, we're going to end up at +1. If we plug in 1, we get 0 out. That's a constant. And last, if we plug in our b value, because it's a fraction, it's going to end up giving us -1. And you can see that your function kind of does this. What's the one thing that we forgot this time? Was our asymptote. still along the y-axis. Real quick, let's talk about domain and range. A domain here now we can see is being restricted along this y-axis, right? So in this case, our domain is limited to anything positive. Our range, however, we can get anything out, right? This thing's going down forever, and it's going this way, which is somewhat up forever. So our domain is going to be limited to whatever our asymptote happens to be. Our range is going to be all real numbers. Where is that asymptote going to end up falling? You'll see in a second. Let's check out our transformations first. Okay, here's our general look for a logarithmic function, right? If we have a plus or minus value, as you can tell by now, a negative is going to flip over the x-axis. Okay, that's just like pretty much every function we've worked with. Here, our a value, same idea as before. If a is greater than 1, our function will look taller. If a is between 0 and 1, it'll look wider. Our base, we want to keep track of what our base happens to be, because again, that's going to affect what happens up here with our parent functions. This left or right shift here is where we're going to find our asymptote. However, let's not forget, we want to move the opposite direction of the sign. Okay, so this is a very important piece here for log functions, right? It's a left-right shift, opposite of the sign. It's also the location of the asymptote. And last, we have k, which is your up and down shift. And we're going to follow the sign on k. So let's take an example here. Okay, I'll leave maybe that up here so we can keep looking at it. All right, we have 2 times log base of 4 of x plus 2 minus 1 is a function that we're trying to graph. So there's a lot of stuff happening here. But we're going to break it down step by step. First, that's going to be taken care of is our asymptote. We look here for our asymptote, but we want to change the sign, so we're going to put our asymptote at -2. By the way, you might have noticed with my graph that I have this spaced apart with little halves. It's very possible that I might need some quarters, so in between each of these spaces, right, because I have a 4 here, so I'm thinking quarters. So just set up your graph anyway that it's easy to work with. So first we put our asymptote. Okay, next I'm going to do my first critical point, which is going to be at 1, 0. However, we're going to be moving 2 left and then 1 down. So 2 left and then 1 unit down. Here's our first critical point. That coordinate is -1, -1. Okay, our second one, because this is a value greater than 1, if we plug in our b value, 4, we're going to get 1 out. So we're up here at 4, 1. However, this 2 is telling us that our distance is going to be twice as tall. So instead of us landing at 1, we're going to land up here at 2. Then we're going to move backwards 2 and down 1. So backwards 2 and down 1. That puts us at 2, 1. Our final point, if we plug in 1 over b, so 1/4, we're going to fall to -1. But we're multiplying that distance times 2, so we're going to fall down to -2. Then we're going to move backwards 2 and down 1. Now this is 1/4, so I need to land 1/4 in front of -1, and then I need to land 1 more in front of -2. So here we are, and we got to drop down 1 full unit thanks to this. So dropping down a full unit puts us down here. Where is that? Well, that's 1 3/4. negative 1 3/4, and negative 3. Here's what the function is going to be doing. Goes through this point, starts turning this way. As far as domain and range, well, we can include everything from here forward. So our domain is going to be all reals as long as x is greater than negative 2. Our range has no restrictions. So it's just going to be all real numbers. Okay, I got 2 more examples for us. One for us together and one for you to try on your own. Okay. This time you'll notice that we have negative log of 1/2. So we want to keep track of what that function is going to be looking like, right? If our b value is less than 1 but greater than 0, it has this kind of downward look to it. Okay, so that's what it's going to end up kind of looking like. However, there's a negative, which is going to make it flip, so it's going to end up looking like this in the end, and we're going to shift +1 and then up 2. And notice here, because I have a half, I know I'm working with halves, right? So I made sure that I adjusted my graph that way. So let's do the first thing first, which is our asymptote, opposite of our sign. So we want to put our asymptote at +1 here. Okay. Our first point is always going to be 1, 0. We want to move forward 1 and then up 2. So forward 1 and then up 2 gives us our first coordinate at 2, 2. Our second point, if we were to do our b value, which is 1/2, that's going to give us 1 out. However, this negative tells us that we've got to flip over the x-axis, so we're down here at -1. Then we're going to move it over 1 and then up 2. 1, 2. That location is 1 and 1/2, 1. We've got one more point to deal with. If we plug in our 1 over b value, which would be 2, it would normally spit out -1. But because we're working with the negative, we need to flip to the opposite side. We're going to move over 1 full unit and then up 2. That puts us here at 3, 3. Our domain, all real numbers, as long as x is greater than 1. Our range is not restricted, so it's going to be all real numbers. By the way, we knew that our base was going to be 1/2, which made us think this way to begin with, but because it flipped negative, our prediction came true, and this is what it ended up looking like. So you have one more to try on your own. Okay. Notice how I set up my graph. I have 3 boxes in between to match my base of 1/3. Okay, you're going to need that. Also recognize that this is 2, not negative, so we still want our graph to kind of look like this in the end. So try this one, pause the video, and resume it when you're ready to check your solution. Alright, let's see how you did. I gave you a couple of hints with that. First, we're always going to work with our asymptote, and we want to go opposite the sign, so we want our asymptote here at -1. Next, we're going to plot our first critical point, which is at 1, 0. Now, that one's not going to move anywhere due to this 2. However, we are going to move it back 1 and then upwards 1. My units here are 3 boxes long, so I got to go back 1 and then upwards 1. So we landed our first point here at 0, 1. Our second point, if we plug in our b value, which is a fraction, 1/3, normally we would get 1 out. but we're multiplying by 2, so we're going to be twice as tall up. Then we're going to move over backwards 1 full unit, so that would be 3 boxes, and then up 1. So here we are. That coordinate, well, that's negative 1/3, negative 2/3, negative 2/3, and we're up here at positive 3. We've got one more point to deal with. If we were to plug in 1 over b, that would really be a value of 3, and it would usually spit out negative 1. However, that 2 multiplies us down here to negative 2. Then we're going to move over 1 full unit, and then up 1 full unit. That puts us here at 2, negative 1. And here's what our function does. It comes down like this, starts turning, and goes on out. Alright, our domain. We want all numbers that are bigger than negative 1. And our range, still unrestricted. All real numbers. So that's it as far as logarithmic functions go. Their graphs and their solving them, not too bad. Very similar to what we've been doing before. Keep track of those 3 critical points and your graphs will come out to be pretty easy to do. If you have any questions, leave them in the comments area, or better than that would be to bring them with you to class and I can answer them there. Till next time.